Okay, well, I said I'd give you a couple more examples of completing the square, but really I just want to give you one more example, and that is, what if we were trying to solve just the general form quadratic equation? Completing the square is actually a method that we can do that. So ax squared plus bx plus c is what we call the standard form quadratic equation, and this can actually be solved without knowing what numbers a, b, and c represent, and let me show you how to do that. Again, completing the square involved having a leading coefficient here of x squared being 1, right? So we don't know what a is. Maybe a is 1, but since a can be 2 or 3 or whatever else, let's go ahead and divide everything by a to start. Whoa, I almost divided by b. There we go. Here and here. So then this gives us x squared plus b over ax plus c over a equals 0. And remember, what we're asking ourselves now is, does the constant term, in this case c over a, represent half of this middle coefficient b over a squared? Well, since I don't know what b and c are, I can't really say that it does. Certainly, this is just an a instead of an a squared, so let's assume that this c over a does not represent half of this middle term squared, meaning that we need to subtract c over a from both sides. Okay, so now this gives me x squared plus b over ax. I'm going to leave a little space, equals negative c over a here. And what the little space is to do is leave me a place here to add half of this middle term squared. So let's do that. Add, parentheses, 1/2 times b over a, quantity squared. There's half of the middle term squared. And I've got to do that to both sides. Half b over a squared. Now this half b over a is just b, 1 times b is b, over 2a. So the binomial we end up with over here is x plus, because there's a plus here, b over 2a quantity squared. This binomial squared is this trinomial. On the right side, let's do a little simplifying. So we've got negative c over a plus, I'm going to go ahead and square this. 1 times b is b, so b squared on the top goes there. 2a, that quantity squared, is 4a squared. Now I'm going to keep going with this so that we end up with something that you'll notice in a conventional form. So let me go ahead and get a common denominator between these two fractions, which means I need to multiply the bottom here by 4a and the top by 4a. So this gives me negative 4ac over 4a squared plus b squared over 4a squared. I can apply this negative to the numerator, and I'm actually going to reorder it also in adding these fractions. I'm going to put the b squared first, and then the negative, or minus, 4ac, all goes on the top. And all of that is over 4a squared. Okay. In the next step, I'm going to take a square root of both sides of this equation. So let me rewrite this. This gives me x plus b over 2a quantity squared, but I'm going to take a square root of that. And on the other side equals, don't forget your plus and minus, the square root of the simplified fraction over there. B squared minus 4ac all over 4a squared. And remember, when you have the root of a fraction, you can call that the root of the top over the root of the bottom. So this comes out as plus and minus root b squared minus 4ac on the top, all over the root 4a squared. And this actually comes out to a perfect value, in fact 2a, because 2a times 2a is 4a squared. So let me just write that. This is plus and minus then the root of b squared minus 4ac all over 2a. Now on the left side of the equation, all we have is x plus b over 2a because we've rooted this square. X plus b over 2a is then equal to what we came up with over here, plus and minus the root of b squared minus 4ac all over 2a. So we're almost there. All I need to do is subtract b over 2a from both sides of this equation. And that leaves us with the following. X is equal to negative b over 2a. I've subtracted it from both sides. Plus and minus the root of b squared minus 4ac all over 2a. And you might notice that we have a common denominator here. So I'm going to rewrite this just in one more form. This negative I will apply to the numerator so that we have x equals negative b plus and minus the root of b squared minus 4ac. And all of that is over 2a. And what you see right here represents the solutions of any standard form quadratic equation. And this right here is named the quadratic formula. Quadratic formula. So just to sum up, the quadratic formula are the solutions, two solutions, one for the plus, one for the minus. The quadratic formula are the solutions to the standard form quadratic equation. Now, depending on how this b squared minus 4ac ends up, you might end up with only one solution. If this comes out to 0, then the only solution you would have is negative b over 2a here. But if this is non-zero, then you have either real or imaginary solutions there. So let me go on to a different section where I will talk more about using the quadratic formula to solve problems. But I just wanted to show you that the solution here, the quadratic formula, can be obtained by completing the square.